In 9.6, this is the last section of Unit 9. Unit 9 has been entirely on factoring. Now, what I would tell you about 9.6 is that it really will start to mix everything together, which is a good thing for you in some regards, because when you take your quiz, you don't know if it's coming from section 1 or section 2 or section 3 or 4 or 5. You don't want to learn just a bunch of different sections. What you want to have is a variety of different techniques that you can use, in which you can factor things or multiply them or combine like terms depending on what the situation is or what you're being asked to do. Worksheet 6 mixes it all up. Don't forget all the techniques you've learned so far. There are no new techniques, which is a good thing. The second thing that I wrote down is that sometimes you're going to factor things and you might get something like, in parentheses, 4x minus 7 times in parentheses 4x minus 7. If you factor something and you get 4x minus 7 times 4x minus 7, then what I want you to know is that on any multiple choice test, on any SBAC, SAT, ACT that you take, the choice or the answer will always be written this way, where you put both things together with an exponent outside the parentheses. So if you factor and you get this, what I'm going to ask those of you that understand what I'm talking about, write your answer like this. It's easier. It's also how higher level mathematicians write it, and it's how it's written on tests that they use for college. Okay? So with that being said, I'm just going to write down, it's because the SBAC's that way, the SAT's that way, and the ACT writes it that way. Now, if you left your answer like this, would I still give you full credit on your test? Absolutely. Most math teachers will. They say, well, they knew how to factor it. That's the main idea. But if you want to write it with the least amount of characters, this is the way to write it with the least amount of characters. It means the same thing. Lastly, our third to last is this GCFs. I wrote this down because in some of your problems, you're going to factor out a GCF. They do not just disappear. Why do I say that? Because after year after year after year, I will grade tests and people will factor out the GCF and then they just like make it go away. Or they forget about it. If there was a GCF in what you started with, there should be a GCF in your final answer. Don't forget that. They do not just go away. They are in front of your final answer, because that's a common thing that happens, especially when we get to this last section. Lastly, a factor is a piece that multiplies. If I ask you to figure out what the factors are, then you just tell me what are the pieces that multiply to be that particular solution or that expression. If you are given a volume and asked for possible dimensions, what are possible dimensions? They're basically saying, what are the factors of the prism? Factor it. What are the pieces? What's a possible length, width, and height? If you can do that, you can answer the question in a question that looks like number 18. Guaranteed to see something like this on your chapter test too, by the way. So I have 1, 2, 3, 4, 5 different examples for us to do together. If you would like to do these examples with me, you are totally welcome to do so. Thank you, Cam. This is number 5 on your worksheet. The first thing that you should always look for is there may or may not be, but we should check. Is there a GCF? Is there a number and or variable that can go into all 3 terms? Let's see. 2 goes into that. 2 goes into that. Does 2 go into 25? No. 5 goes into that. 5 goes into that. 5 does not go into 36. 3 goes into here. 3 goes into here, but 3 does not go into there. So there's no number that goes into all 3. But I see that this has x to the third, x squared, and has an x. Because they all have the same variable, I can factor out a GCF of an x. If I factor out a GCF of an x, there would be 36x squared left if I pulled one x out. if I factor out an x, I would have 60x left over if an x had popped out. And if I factored out an x, the 25 would be what's left there as well. So right now I've done the GCF. And this is where you're going to need to ask yourself, does this factor further? Using a technique I learned in section 4 or section 5. The GCF does not go away. It stays in front. That's one of the reasons why we wrote that down in our notes. But this is also where you need to start thinking, what multiplies to be 36x squared? What numbers? So if you're thinking 36 times 1, 18 times 2, 12 times 3, 9 times 4, 6 times 6. That's a lot of different possibilities, and I didn't even write it in the opposite direction. And then I go over to the 25. 25 and 1, 1 and 25, 5 and 5. What we're trying to do is we're trying to find the combination of numbers that when you multiply them, the outside plus the inside will add to be to that 60. Because we have a positive and a positive, I don't think that anything's going to be negative here. I think everything's going to be positive, so they're going to add to be a positive 60. If you don't know where to start, pick something right in the middle, or maybe the smaller things, because then you can always get it bigger. But if you start at the biggest one, it just depends. This is kind of like sort of double that. So I'm just going to pick something right in the middle. I'm going to hopefully pick some numbers that are in the middle. Here's what I'm doing. I'm going to pick a 6 and a 6 and a 5 and a 5. Here's what I'm going to check before I write anything down. Left number times left number. 6 times 5 is 30. I keep that number in my head. Right number times right number. 6 times 5 is... Now put those two numbers together, 30 and 30. Does that make the 60 in the middle? If it does, you've picked the right numbers. If it doesn't, you have to pick a different combination of numbers. I got lucky. I picked the right one right off the bat. So now how do I write that? I don't just use the 6 and the 6. There's a variable here. I need 6x times 6x to get to the 36x squared. I also need, we said it's going to be 5 times 5 to equal 25. I'm going to put the 5 in here and the 5 in here. And then I need them both to be positives. Now just to show you, I'm going to put the box. I'm not going to put the box around there. Just to show you, I want to FOIL this out. This times this is 36x squared. This times the 5 is 30x. The inside, 30x. 30x and 30x makes 60x, and positive 5 times positive 5 is positive 25. So that is equivalent to the thing above it. This is not the easiest way to write this answer. On the SATs and ACTs, what they're going to do is keep that GCF in front, and these two groups are the same. So what they'll do, and what we're going to start doing, if we see it, is we're going to say there's two factors of 6x plus 5, and that is the easiest way to write that answer. What I like about starting with this is it has a GCF, and we started talking. That's one of the first things we said. GCFs do not disappear. How to use an exponent for the final answer of a binomial squared. That we get to use both of those things in that first problem. Let's jump to number 9. I look for a GCF. There's no number that goes into all three, but they do all have a D in common. I'm going to factor out D as a GCF. If you pull out one of the d's, you're left with 3d squared. If you pull out one of the d's from here, it's 20d is left. If you pull out one of the d's, 12 is left over. And you can always check this by distributing to see if it's still the same thing. The GCF does not disappear. It stays in front. We have this trinomial squared, so I'm going to have to try to see if I can figure out the factors. This one's going to be easier because 3 is a prime number. 3 times 1 is the only way to get to 3. That's kind of nice. 12 is a little bit more difficult because it's 1 times 12 or 2 times 6 or 3 times 4 or the other way around. So knowing that, we got to find the one that's going to make this plus 20. How are we going to do that? I just start picking and guessing. I do left number times left number. That's 9. 3 times 3 is 9. Right number times right number. 9 and 4. 9 and 4 make 13. No, it doesn't make 20. I picked the wrong one. 3 times 4, 12. 12 and 3. 12 and 3 is 15. Doesn't work. 6. 6 and 6 make 12. That doesn't work. Left number times left number. 18. 18 and 2. 18 and 2 make 20. That's what I want. I want to use these combination of numbers. The way I just explained how to figure that out is what you are going to have to do. You are going to have the same process when I say, oh, this is how we figure it out. Left number times left number. Right number times right number. And what does that add to be? So now that means I want to split this left piece up into the 3 and the 1. I'm going to put 3D. Don't forget the variable. The 1D, I don't need to write the 1. This is 3D, and that's the 1D. I wanted the left number to multiply this 6. So that means the 3 for the outside needs to multiply a 6. The 1, which is this piece, needs to multiply the 2. I need the 2 to be here for the inside. I want this to multiply to be 18D as a positive. That means this 6 has to be a positive. I want this 2D to be a positive 2D. The reason I want these to be positive is so that 18D plus 2D will equal 20D. If you want to double check, 3D squared plus 18 plus 19, 20 is 20D, plus 2 times 6 is 12. This is equal to that. It's factored. There's your final answer. Now, number 16 is a same kind of question, except it's multiple choice. It says, which of these expressions is not a factor of? So my advice to you is going to be factor it. Find out what the factors are and then see which one doesn't work. So if you're looking at this, factor out a GCF of an x. If you factor out a GCF of an x, let's see what's left. 5x squared minus 17x plus 14. X is a factor. Which of the following expression is not a factor? Well, I know x is a factor. Leave the GCF right out in front. And then you have to look at, man, this can probably split apart. The good thing is the 5 is prime. 5 times 1. The 14 is not prime, so we got to look at the 1 and the 14, the 14 and the 1, the 7 and the 2, and the 2 and the 7. It's going to be one of those combinations. Now we have a negative this time, a negative 17, but a positive 14. It's going to multiply to be a positive, but add to be a negative. That probably means it's going to be a negative and a negative, by the way. So let's do left number times left number. 5 times 14 is a big number. That's like 70. And 1. That's not going to make 17. 35 and 2. That's not going to make 17. 10. 5 times 2 is 10. 1 times 7 is 7. 10 and 7. That can make 17. So let's use those. Let's use 5x. Got to keep the variable. And the 1x. I don't need to write the 1. I want the 5 to multiply a 2. I'm going to put the 2 right here so that the outside is 10x. And then I want the 1 to multiply the 7. I'm going to put the 7 here so that the inside is 7x. What I am seeing is I want these two to add to 17, but that 17 needs to be negative. If this 7 was a negative 7, that would make that negative 7x. If this 2 was negative, then that would make this negative 10x. And these two added together would make the negative 17. And a negative 7 times a negative 2 is a positive 14. This is a factor. This is a factor. This is a factor. The question says which of these is not a factor. 5x minus 7 is a factor. X minus 2 is a factor. The only one that is not a factor of this is C. My recommendation is factor it if it says which was not a factor. That way you know what the factors are. I'm going to go to number 18 next. Number 18 says, this prism has a volume of 10x to the third plus 11x squared minus 8x. What are 3 factors that could represent the possible dimensions of the rectangular prism? They are asking you, what could be a length, a width, or a height? And they didn't say which one had to be which. So you could have the width, the height, the length, the length, the width, the height, the width. You could have any combination you want. All you need to know are what are the factors of this volume. So if you know that this is the volume and that the volume is a length times width times height, you basically have to change this from what it is and factor it into pieces that multiply to be it. How do I do that? I'm going to factor out a GCF of an x. Then that would leave 10x squared plus 11x minus 8. If the GCF is an x, what I then can do is break apart the 10 into 1 times 10 or 2 times 5. I can break apart the 8 into 8 times 1, 4 times 2, or 2 times 4. It's going to be a negative 8, so I know that means 1 needs to be a positive and 1 needs to be a negative. And we're looking for something that adds to be 11. So, left number times left number, 8 and 10. 8 and 10. That doesn't make 11. 4 and 20. 4 and 20 does not make 11. 2 and 40. Nope, that doesn't make 11. 16 and 5. Ooh, that might work. 16 and 5. 16 minus 5 is 11. I think that's the one that I want. By the way, if I went through all of them and this didn't work, I'd use the 1 and the 10 and then go through all 4 of those as well. So I'm going to put a 2x here because I got to have the variable with it. And then the 5x here. 2x times 5x is 10x squared. I want the 2 to multiply the 8. I want the 2 to multiply the 8, so I put the 8 right here. I want the 5 to multiply the 1, so I'm going to put the 1 right there. I want this 16x to be positive. I'm going to put a plus sign on the 8. I want this 5x to be negative, so that 16x take away 5x is 11x. And now what I have is I have this volume broken up into 3 factors. What are 3 factors that could represent the possible dimensions? This could be the length, width, or height. This could be the length, width, or height. Or this could be the length, width, or height. All you have to do now is put your factors, and then the order does not matter. You just split up all the pieces that you found. This group, this thing. Those are my 3 possible dimensions. Your last example is 21. 21 goes back and says, do you know how to do a GCF? If you do, you factor out the GCF of a 3. The 3 does not go away. It stays in front. And then they're going to see, do you remember how to factor the difference of squares? This is a perfect square. 5n times 5n is 25n squared. This is a perfect square. P times p is p squared. Perfect square, and a subtraction, difference of squares. We take the square roots, and you put the square root of this times itself to equal that. You take the square root of the last term, p times p is p squared. And the only thing that we do with this is we put the plus sign and a minus sign in between the square roots for the difference of squares. Why? That way the outside makes a negative 5np and the inside makes a positive 5np. Then those will cancel each other out. This is your final answer for 21. I'm going to stop your notes right there.